Welcome students to MKG Online Study. In today's lecture, we will deeply understand the difference between multiplexing techniques used in communication systems. We will compare three important techniques: frequency division multiplexing (FDM), time division multiplexing (TDM), code division multiplexing (CDM). These techniques form the foundation of wireless and mobile communication system. First, we will understand what multiplexing means. Multiplexing is a technique that allows multiple signals or users to share a single communication channel. In real life, bandwidth is limited. We cannot dedicate a separate channel for every user. Therefore, multiplexing helps us efficiently utilize available bandwidth. For example, imagine a single highway that must be shared by many vehicles. Multiplexing decides how vehicles use that road. Let us understand, why do we need multiplexing? Because there is limited bandwidth resources. Number of users are increasing. Efficient spectrum usage is necessary. Infrastructure cost must be minimized. Without multiplexing, communication system would be very inefficient. Frequency division multiplexing. In frequency division multiplexing, the total bandwidth is divided into smaller frequency bands. Each user is assigned a different frequency band. All users transmit simultaneously but at different frequencies. Important points that are guard bands required to avoid overlapping, mostly used in analog system, simple to implement. For example, we can say radio station operate on different frequencies: 98.3, 102.6 megahertz. This is FDM. So you can see here we are having different sources, that from that we are getting some input signals, and they are having different frequency band, like radio station 98.3, 94.6. So they are having different frequency band. So FDM is like giving each car a separate lane on the highway. So this is how FDM works. Next is time division multiplexing. In time division multiplexing, all users share the same frequency, but transmission happen in different time slots. Time is divided. You can see A, B, C, D. There are four sources. They are sending some data A, B, C, D. Here, times are divided. A is sending data in this particular slot. B is sending in this particular time slot. C is sending in this slot. And D is sending in this particular time slot. So each frame has multiple slots. Each user transmit only in their slot. If they don't have data, that slot will be passed on. Process repeats continuously. So time slot is divided. Each user transmit in allocated slot, requires synchronization. If timing is disturbed, data may be overlapped. So example, GSM networks. GSM mobile networks use TDM. Imagine one single lane road and cars pass one by one in fixed order. Let us move to code division multiplexing. This is more advanced. Here, all users transmit at same time using the same frequency. Each user has a unique code. Signals separated using decoding, high security and complexity. You can see here the users are sending the data in some particular code with the same frequency and the same time slot. Here, spreading codes, orthogonality, higher capacity, more secure, complex receiver design. You can say that example may be 3G mobile system, military communication secure wireless system. We can say that all people speak in the same room at the same time, but each speaks a different language. If you understand the language, you can decode the message. This is how this particular CDM works. They are sending same code with some variations, some coding, the user or the receiver that can decode that code that uses that particular code. Let us compare them. FDM divides frequency, TDM divides time, CDM divides code. Bandwidth usage divided into frequency bands, shared in different time slots, entire bandwidth shared. Transmission time simultaneous, one at a time, simultaneous. Frequency usage different frequency for each user, same frequency, same frequency. Guard bands. Guard band is only required in FDM. TDM and CDM do not require guard bands. Synchronization is not very critical. Here it is very important. Here it is required. Interference. Possible if guard bands are small. Low if synchronized. Minimal if ports are orthogonal. Complexity low, medium, high. CDM has high complexity. Efficiency moderate, high, very high. Security low, moderate, high. Power control is very important in CDM, not critical in FDM and TDM. Typical application FDM, radio broadcasting, cable TV, TDM, GSM, digital telephony, CDM, 3G mobile network. Signal type FDM mostly analog, TDM digital, and CDM digital. Receivers design FDM simple, TDM moderate, CDM complex. So basically, we understood today that FDM divides bandwidth into frequency band, TDM divides transmission into time slot, CDM separates user using unique codes. Also, from exam point of view, you can just remember that FDM divides frequency, TDM divides time, CDM divides code. FDM uses guard band, TDM uses time slot, CDM uses unique separating codes. FDM is simple, TDM is efficient for digital system, CDM provides high capacity and security. So, comparison FDM, TDM, and CDM. So, this is the conclusion that FDM is simple but less efficient. TDM efficient for digital systems. CDM high capacity and secure. Selection depends on application. The choice is of users. User want to send the data simultaneously or separately with high capacity or security. It depends on the application. Thank you for watching this video.